all of you that whenever you join any class, so these are the common guidelines that you have to remember for all sessions. So enrollment number and program number should be shared in the chat so that we can mark your attendance. If you want to ask any question, then you can raise your hand or you can write in the chat. And basically, we discuss at the end of the session. If there is any doubt, I'll also ask you in between. Okay. Avoid posting irrelevant questions. Right. There should be relevant questions related to the topic only. And interaction with the faculty should be constructive. Right. The, the topic should be related to that topic only, and it should be constructive also. Okay. And these are the some numbers and email IDs. If you have any doubt or any issue related to that, you can post your issue. So learning objective of the session will be, you complete the session, then you can explain what is electric current. You will also study EMF, potential difference or voltage, right? Electromagnetic induction, what is Ohm's law we will study about, Faraday's law, and all the circuits and types that we have and components also of all the circuits we will study. By the end of this session, these are the learning outcomes. So you can explain the electricity at the end. What is the phenomena behind EMF and potential difference? You can discuss circuit and its component and what is Faraday's law and its application. Okay. So as I told you that whenever we talk about the working of any appliance that we generally use, so there is electricity behind that. Okay. And if electricity is not there, so can you imagine what will happen? In earlier days, or if we talk about 50, 60 years back, there was no electricity, right? And how they survived, the person who were at that time, how they survived without electricity. And if electricity was not there, then the appliances that we are using were also not there. Okay. So you can understand that how much electricity is important. What is the importance of electricity is in our life, you can understand. So as you can see that there's a refrigerator, mobile phones are there, so we have to charge it. Okay, fan, AC, bulb, tube light, mixie, so many things are there, and everything is dependent upon the electricity. So if electricity is not there, then we cannot use these appliances, right? You can see the mobile phone in anyone's hand. Okay, if he is walking, mobile is there in hand. If he is going to sleep, we see the mobile first, then after take rest. Okay, so mobile phone is very useful nowadays. And to charge it, we have to use a charger, and charger can be working with or using electricity only. So without electricity it is not possible. So how electricity is reaching at our home, right? So it is actually due to electric current. So what is electric current? So as I told you that it is providing the energy. Okay. So electric current is the source of energy so that it can work. Okay. If electric current, because current flows, right? And if current is not flowing, then electricity will not be there. Okay, so electric current should be there, and electric current is providing the energy to the appliance. Suppose we talk about our body, human body. So what we do, we take food. Okay, why do we take food? Because the energy is required for a human to work, right? Similarly, there is electric current for the appliances. Okay, so it is basically the important concept of that, and without existing the current, it cannot work, right? So we will study what is basically electric current. So current is actually the flow of charge. right? If charge is flowing, then current will flow. And what is the role of electrons? What is the role of the electrons? So from where we got electrons? Have you ever studied about electrons? Electron, neutron, proton. So have you ever studied or have you ever heard about this term, electron? Yes, Aman. What do you know about electron? Yes, Aman, you can tell me. Okay, no problem. If you see any material using microscope, okay, so there will be orientation like this. This is one nucleus, okay. In nucleus there will be protons and neutrons, and these are the orbits. These are the orbits. On these orbits, electrons are moving like this. Okay. You might have studied in chemistry, orientation. Okay. Structure, orientation of the material, right? So in this orientation, there will be one nucleus, and in this nucleus, there will be protons and neutrons and electrons. These are the electrons that are moving on the circular path, and this is known as orbit, right? So these electrons are actually moving outside this nucleus in this round, right? You can say circle, right? So this is the circular path. So these electrons are moving, and these number depending upon the material to material. Okay, so it is already studied, right? So these are those electrons, and these electrons are playing the role in flowing the current, right? So if we talk about the definition of current, then current is the flow of electrons in the circuit. If electrons are moving, then current will also flow. If electrons are not moving, then current will not flow. Okay, so this is atom, right? So this is the structure of atom in which there will be one nucleus and electrons are moving around it. Clear? These protons are positive charge, neutron are neutral, right? And electrons are negative charge. The charge, if we talk about the charge, then protons will have positive charge and electrons will have negative charge. So these electrons are negatively charged particles, right? Clear? And the current is movement of free electrons. Now you have to understand what is the difference between electrons and free electrons. There's difference by adding free. If we add free with the electrons, the meaning is changed. What is that? Electrons may be bounded, may be bounded means these electrons can move in circular path, but it cannot become free. Free means it is not moving here, it is moving random, any direction. It will not flow in particular circular direction, it can move like this, here, there, anywhere. So this electron is now free electron. And how it become free? After getting the sufficient energy. Suppose one animal is there, right? And animal is tied with the rope. Okay. So due to that rope, that animal cannot move anywhere. But after cutting of the rope, right, or breaking of the rope, it can move anywhere. It will be free at that time. So how the rope was broken? Because animal has applied sufficient force on it. Okay, and due to that the rope was broken. Similarly, electron has got the sufficient external energy, and that energy is sufficient for making this electron free. So it is not more bounded, it is free. So current is flowing due to these free electrons, not bounded electrons. They are not binded electrons. Okay. So free electrons are required to flow the current in the circuit. Okay. So have you understood the difference between electrons and free electrons? Any doubt in this? Okay. Mohit, we will mark attendance. We don't know. No, don't worry, right? Right. Okay. Now we discuss about this diagram. What is that? The material is there. Okay. If we have not applied any potential difference, and potential difference is actually voltage. You have heard this word voltage. So voltage is nothing but potential difference. Okay. So if anywhere potential difference is there, you should know it is voltage. So these are free electrons. Okay. But we have not applied any external voltage using battery or any source, right? So these electrons are free to move in any direction. So you can see that this electron is moving in this direction, this is moving in this direction, this is in this direction. So all are randomly moving, but current should flow in particular direction, right? If current is flowing in this direction, it means all the electrons are moving in this direction only. But due to this random movement, it is not possible. So for this, what we will do, we will apply potential difference, that is voltage. So we have applied now voltage across this material. So voltage will be, suppose this is positive terminal, this is negative. Okay. Source, suppose we have applied voltage using battery. So this is positive terminal, this is negative, right? So this positive is this, actually. Negative is this. So after applying this voltage, that random motion which was here, this was random. This was random. Now it is not random, it is in particular direction. So what will be the direction of the flow of electrons? It will be decided by the source, right? So what will be the direction? So I told you in the beginning that electrons are negatively charged. Electrons are negatively charged particles. So if it is negative, then it will be attracted by positive terminal of the source. So positive is where? Positive is here. That is why negatively charged electrons will move in this direction. Right? If we apply like this, so electrons will move in this direction. Right? So you should know in which direction electrons will flow. Electrons movement is depending upon the terminal of the source, right? So wherever the positive terminal is there, it will move in that direction only. Why? Because this positive terminal of the battery will attract the negatively charged particles, that is electrons, right? To move any electrons, we need some force. So that force is actually electromotive force, and in short we write EMF, right? So EMF is what? That is required to move the electrons in particular direction, in a specific direction, so that the movement of charge can be there. And finally we will have the current. So electromotive force is required. Now, what is difference between EMF and voltage, right? So I'll tell you using the battery, right? This is battery, and if generally we see the battery like this, these are two terminals. One is positive, second is negative. Inside that there will be cells. Do you know what is cell and battery? Is it battery or cell? It is actually battery. It is actually cell, right? Cell is a single. This is positive, this is negative. If we talk about the battery, then there will be series of the cells. So one cell is this, second is this, third is this. So one, two, three. So this is a combination of three cells. So this will be positive terminal, this will be the negative. If you want to add more, you add, right? So all these cells are in series. Negative of previous is connected with positive. What is series and parallel? So series means negative of the previous should be connected with the positive of the next. And again, this negative is connected with the positive of this. This negative is connected with the positive of the next. So this is series combination. So series combination of cell will make one battery, right? So if this is battery and this is positive terminal like this, and this is negative like this, okay, all cells are connected in series here. So positive will be started here and negative will be ended here. So if we connect voltmeter, what is voltmeter? I'll tell you everything about the terms that I am using. So voltmeter means the meter which is used to measure voltage, right? Voltage. So voltmeter is like a meter, right? So whenever we connect the terminals at the positive and negative, what this voltmeter show, it will show the voltage value, what voltage value is there between these terminals. So in this battery we have not connected any external appliance or load. What is load? Load is that consumes the energy, right? Load is what? That consumes energy. So we have not connected any load. Bulb is load. Why? Because it is glowing using the energy. If we connect the fan, fan is what? It is load because it will work using energy, right? So anything that consumes energy is load. So we have not connected any load with the battery. So even this voltmeter will show something, some value, and that value will be EMF, right? That value of voltage will not be voltage, it will be EMF, that is electromotive force. So electromotive force is actually the value that is without load, without used by any load, okay? But whenever we connect any load, so the value across that load will be potential difference, that is voltage. So potential difference, why it is difference? Because there will be voltage drop across that. Okay, so you should know what is EMF and voltage. So voltage is using load, EMF is without load. You can remember like this. Okay, understood? Everyone understood this thing? Have you all understood the difference between EMF and voltage? Tell me. Okay, thank you, Aman. So I'll ask in between. Okay, so if little bit discussion can be there. Okay. Yes, bole. You can say it is right. Right. Bole bilkul. So you can see here that these are the ions. So you have to go in depth of the material, right? Like semiconductor. So in semiconductor, we have P type and N type semiconductors, right? What is semiconductor basically? So if we classify the material, there are three types: conductor, insulator, and semiconductor. Okay. So what is conductor? So conductor material are those material in which the flow of electrons is very easy. Very easy means very less voltage is required to flow the current. If this is conductor, the flow of current or flow of electrons is very easy. But in insulator, it is easy. But insulator, it is impossible. Right? It is not possible. Means there is no flow of electrons. That is why there is no there is no current, because current is due to flow of electrons. So there are no electrons moving in insulator. That is why there is no current. So it is not possible. The conduction is not possible in insulator. So in conductor it is easy, it in insulator it is impossible. But semiconductor is the material that falls between these. Like here, the flow of electron is neither easy nor impossible. राइट ऐसा भी नहीं है कि बिल्कुल फ्लो ही नहीं हो सकता और ऐसा भी नहीं है कि बहुत इजी हो बट but we have to flow the current, so external force is required there. A little bit external force is required. So there are two types, p type and n type semiconductor. So it is not directly types of semiconductor. The types of semiconductor are pure semiconductor and impure semiconductor. Pure semiconductor is known as intrinsic semiconductor means pure semiconductor. The material is given to you, you are using as it is. But extrinsic will be external thing is added, that is impurity. So after adding the impurity we have two types, p type and n type. So these are impure semiconductor because we have added the impurity, right? So p type semiconductor is developed using trivalent and n-type is developed using pentavalent impurities. Clear? So in n-type, electrons are majority charge carrier and in p-type, there are holes. So holes are majority charge carrier, electrons are majority charge carrier in n-type. But it doesn't mean that in p-type there will be no electron. It doesn't mean that in n-type there will be no holes. There will be, but in very less number. That is why those charge carriers will be known as minority charge carriers. Clear? So how do we show like this? Okay. So this is electron. This is actually n-type. Electron is showing here. and this plus is showing because electron is accepting something, right? It is accepting, or it is, suppose donor may be there, so they will be negative, so here it will be, actually I have to show whole here, then I will fill it. So this filling, what is happening, just a minute. So I am showing like this, right? So these are holes and these are electrons. So this is a difference. So electron is actually given, which because it is extra. So this is donor ion, and due to this is positive. Donor means जो देता है, so it will be positive, and it is whole. Whole is the vacant space. It is free space, right? Like vacant chair is there, so anyone can sit there. So this is actually accepting something, so this is accepting, that is why it is negative. So this donor ion is showing here. So this is positive, this is electron. Clear? So electron is free electron. So free electron means it will give, it can be given to anyone. So how can you give if you don't have anything? So you should have something to give. That is why you are donor. Blood donation camp is there. So what is there? You donate the blood. So you are giving actually. You have, that is why you are giving. That is why it is positive. So this is donor ion. This is donor ion, this is electron. Clear? So these are metal ions and free electrons from outer shell of metal. Clear? So you can see here some material allow free and faster flow of electrons and some don't. So in free and faster it is conductor or maybe semiconductor. But in this case it will be insulator. Clear? And difference is in availability of free electrons. So if current is moving very fast or high current is there, it means more electrons are there. So if in one wire there will be less current, in another wire there will be large current. What is the difference? The difference is of free electrons available in the material, right? So due to the difference, the current will flow high or low. So higher availability means higher free electrons. High conduction will be there. It will conduct higher than another one. Clear? So depending upon the number of free electrons, the current will be high. Conduction will also be high. What is conduction? What is conduction? Conduction is when current is flowing in any conductor, then there will be conduction inside that. If current is not flowing, there is non-conduction, right? So you can see here, these are conductors. If current is not flowing, insulator. But if current is flowing, but after applying some external force, is the semiconductor. Clear? Very easy conduction, conductor. Non-conduction, it is not possible, insulator. But between these two materials, this is semiconductor. That is why semi means automatic, semi-automatic. What is difference? Automatic means it can work itself very easily, but semi-automatic means you have to do something, like washing machine. Automatic washing machine means you just pull down the clothes, fill the detergent, and you will get the washed and spent clothes. But in semi-automatic, after washing, you have to shift that for spinning, right? Rinse the water, then you will get the work. So a middle work was also done by you in semiconductor. So in semiconductor, there will be Not very easy conduction, but conduction is possible. This is this. Give some force to do. Yes, बोले. यस वंश हमको ही भेजनी है ना. So I hope you have understood this thing. This is very easy thing. Now, I told you that current electrons are moving, but what will be the direction of current, right? So you should know that if electron is moving in this direction, then current will be flowing in this direction, right? So the direction of current is opposite to the direction of electrons. So if electron is moving from left to right, then current will flow from right to left, right? Or vice versa. Clear? So you have seen this diagram that we applied the force, we applied or we connected the battery. So force was applied. So electron is moving in this direction. Why? Because this is positive. And if electron is moving in this direction, then current will flow in this direction. Clear? Right? So you can say that current flows from positive to negative. But you should know what is the reason behind that. That is, we have applied the force, the voltage using this battery, right? And due to the flow of electron in this direction, the current will flow in this direction. So this direction means like this. So in general, we can say that current flows from positive to negative. Clear? You have to understand this, that why the direction is this. So this is actually the direction of electrons. So current is flowing in opposite direction to the movement of electrons. And why it is using moving in opposite direction? Because if electron is moving in this direction, so charge is left here, again here, charge is here, again here. So you can say that charge is actually moving in this direction, like that. So this is the imaginary actually, right? So you can say that due to this region the electron is moving in this direction, right? Now we have to calculate the current, that what is the value of the current. So how can you get that? If you don't have the voltage value, then what formula will be used there? So you have this formula, that I is equal to Q upon T, right? You can write this Q by T like this, Q up into 1 upon T. You all have studied mathematics. So we can write Q by T like this also, Q into 1 upon T. So 1 upon T is what? Anyone can tell me what is frequency? Have you studied the frequency? What is frequency? No, no, no. This is not wave. Frequency. No, 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 no. No shift. This is not frequency. Mukesh Goswami ji, basic electronics is very, very required subject for everyone. It is not related to BCA or anyone, right? It is the basic subject that you all should study about, right? if you do any project related to communication, right? After BCA, it doesn't mean that you will work on only laptop, but the programming can be related to telecommunication or anything that is related to electronics. Then in that case, how will you imagine that how it will work? Okay, so concept should be there, right? Logic, how can you create the logic if you don't have the knowledge about that? So you should have basic knowledge of this thing. You will study digital electronics also here in this subject. So in BTech, right, MTech, there's digital electronics. In BTech, digital electronics is there. The lab is also there. Okay, so it is required subject. Okay. See my answer, पवन जी क्या कह रहे हैं? Where you have written, Pavan, the measure of how often an event repeats at a specific period. Yes, correct. Okay. So frequency is that happens after fixed time. Or if we say that in 1 second, how many times it is doing the same. Okay. The same work is doing how many times in 1 second is frequency. Clear? So this is actually written here that 1 upon T. So 1 upon T is nothing but the frequency. So if we put value 1, so in 1 second, how many times it is done? That is frequency. Okay. So this frequency is also known as rate. Rate means if we go to any shop, भाई इसका rate क्या है? What is the rate? Rate means one item, the value of the one item. Okay, this is one, right? That is why I have put one here, 1 second. Similarly, this rate is frequency and it is used here. And this is multiply. So you all have studied board mass in mathematics of, right? So in of what do? We generally multiply. So Q of rate or rate of Q, है ना? If you multiply 2 by 3 or 3 by 2, the value is 6, right? So we will put this rate before here. So rate of Q, and this rate of Q is written here. So the definition of current will be the rate of flow of charge. So Q is what? Q is flow of charge. So you can write the definition using this, that what is current. So current is nothing but the rate of flow of charge, that is Q, is known as current, right? So we get the formula from the definition. Okay, or you can write opposite. In which manner or way you can remember, it's up to you. So I hope you all have remembered this formula as well as the definition. So the formula of measuring the current is I is equal to Q upon T. So I is the current, Q is the flow of charge, and T is the time. In how much time or how much second it is flowing, it is the current. Clear? So if we measure any value, if I ask you the distance, so you will say in meter and kilometer. So similarly, there will also be the unit of current, right? So using this formula, what will be the unit? So charge is having the unit coulomb. Coulomb. What is happening? Just a minute. Coulomb upon second, right? Q का coulomb, T का second. Coulomb upon second. So coulomb per second is the unit of current. Clear? But but we use the another unit that is known as ampere. Ampere name is given after the scientist, right? So in place of coulomb per second, we use ampere as the unit of current. In short, we write A, right? Suppose I am saying 2 amperes, so 2A. Clear? So this is the unit of ampere. We will not use coulomb per second. We use the unit ampere for current. Clear? And Ohm's law says, this formula is from Ohm's law, V proportional I. V proportional I means if current is varying, then voltage will also vary. Clear? If current is higher, voltage will also be higher. Current is lower, then voltage will also lower. So V proportional I, and this proportionality will be removed. So proportionality constant will be there, that is R. So V is equal to Ri, right? Or you can write V is equal to IR, same. Okay. So this formula is gotten using Ohm's law. So in any of the circuit, whenever we calculate the current, voltage or resistance value, we use this formula V is equal to IR. So this is very basic and easy formula for everyone to calculate voltage, current or resistance. So out of these three, if you have two values, if you want to calculate anything, so out of three, you should have two values. So you can calculate third one. Three values means V, I, and R. Three values are there. So if you have two, any two, you can find the third one. Clear? So this V is the voltage you have already studied. I is the current, R is the resistance. What is resistance? That resists the flow of current. Resists the flow of current that opposes the flow of current. So resistance may be of the wire, resistance may be external, resistance may be external resistor is connected there, R. So how much value of R is there? Depending upon that, the current will also vary because current is flowing in this direction. So after reaching here, this resistor will resist the flow of current. Clear? So it depends upon resistance. So this formula is also very useful and important. V is equal to IR. So you should remember this formula. So in this example, you can see that 10 ampere current is there and you have 5 ohm. The resistance unit is ohms. Ohm's law, right? So after that name, ohm. This is ohm. So 5 ohm resistor is there and 10 ampere current is flowing in any circuit. What is the value of voltage? So we will use V is equal to IR, right? So I is 10 ampere, so we will put here. Resistance is 5 ohm, we will put here. So it will be 50 volts. So unit of voltage is volts, current is ampere, and resistor is ohm. Clear? Okay, I give you one example. V is equal to 15 volt. I is equal to 3 ampere. What is the value of R? Please tell me. Please calculate the value of resistor. What will be the value of resistor there? पवन जी इज आस्किंग, सर करंट और वोल्टेज के बीच एग्जैक्ट रिलेशन क्या है? अगर रेजिस्टर बढ़ गया तो करंट पे क्या इफेक्ट पड़ेगा? I already told you that after applying the voltage is what? That is the force which is applied on the material, right? So after applying the voltage, the movement of electron will be there depending upon force. If higher voltage is applied, higher electrons will be moving there and higher current will also be there, right? That is why V proportional I. Clear? And if any resistance is there in between, then there will be voltage drop across that, right? What will be the voltage drop? V is equal to IR. We can calculate it. Suppose resistor is, I give you one example. Resistor is 3 ampere. Resistor is 3 ohm, and current is, for example, 5 ampere. What will be the voltage drop? 5 into 3, 15 volts. Yeah? So you can calculate anything. Clear? Okay. So what I gave you, 15 volt, 3 ampere. So you have V, I and R. So using this formula, what do you want to find? R, then we will write like this first. Clear? You have three formula actually. V is equal to IR, R is equal to V upon I, and I is equal to V upon R from the same formula. Right? So which formula is required? Because we want R, so we will use this one. So V is 15 upon 3, that is 5. What 5? 5 ohm. Whenever you calculate anything, you should put the unit also. Without unit, there is no value. Value means there is no importance. So I hope you all have understood this formula and the calculation. So whenever we purchase any gadget, any appliance, anything, so on that box, the packing is there, right? So on that box, everything is mentioned that how much voltage is required, how much current is required. Okay, why anyone say that you should not use another uh, mobile charger? Because every mobile wants different current. If you use the higher current charger, then your battery will be damaged. It can be burst also. Why? Because higher current will be flowing. Your battery of your mobile is wants very less value, right? Somewhere it is zero point 0.5, somewhere it is 0.75, and you are using 0.75 charger, then it will burn your battery because there will be higher force, higher value, higher voltage value will be applied across that. So we should not use that. So that is why on every gadget box it is mentioned that how much current should be used there. So if we talk about laptop, home printer, television, heating kettle, mobile charger, adapter of anything, right? So everything is mentioned on adapter on your mobile of your mobile. You can see there. This voltage, this much current should be applied. So why it is mentioned there? It is already used by you. But if you use another charger, then you should take care of this thing. So in laptop, this current is needed. 0.25 to 0.35 ampere is required when it is being charged. Whenever it is charging, then this current should be there. If you are applying the higher value, continuously higher value, then it can there may be effect on your battery. Okay. Similarly for printing, this value. So every appliance has different required value. This is this, and kettle require very high because it has to heat the element. Then higher current should be there. So it is 10 ampere. So depending upon the working appliance, any gadget, the value of the current is different. Yeah. So there may be some other example of. So we have understood what is current, what can be the value of the current, we can calculate also. But if current is flowing in any of the circuit, then it shows some effects. There may be some signs, right? Signs means sign, effect. So what may be there? So if we are using continuously applying the higher current, right? So there may be effect. So what type of effect can be reflected there? So those type of effects are shown here. So first type of effect is dissipation of heat. If we are applying the voltage, the current will be high and there may be dissipation of heat. So why it is dissipating? What is dissipation actually? So dissipation means if we have applied voltage, then there will be generation of heat. Heat will be generated there. Okay, and dissipation means it will be coming out of it. So this is dissipation. So it can be useful or harmful. So somewhere we are using it. So it is actually application. It is usefulness. So somewhere it is harmful. So this is depending upon the appliance, what we are using. So if we are using any charger, if it is being heated, then we will just keep out of the socket. Why? Because it will be burned. Yes? So this heat is depending upon how much current is there, what is the voltage value, and the resistance of the current conductor. Okay, so it is basically depending upon these three values V, I, and R. So that is why it is mentioned there that it should be this value, not more than that. Little bit difference may be accepted, but if there is large difference, then there will be effect on that. And if current is small, heat generation will also be small, right? Because current is flowing, but it is less than the required value, then it will not be heated. Okay, heat will be generated, but very very less value will be there. Okay, and when it is larger, then heating may be there. So it will start heating, and this is also a application. Application means heating element. Heating element are using this, right? Boilers are using this dissipation. Iron, we use iron, right? So in iron, it is also application. So somewhere it is application, somewhere it is damage, right? There is effect on the appliance. Along with it, there may be magnetic effect where you have seen if you are going through any road, there are high tension lines. Okay, there are high tension lines moving ahead, right? And if you are moving in night, right, there's no vehicle and no voice are there, then you can experience this thing. If you are moving beneath the high tension line, there will be murmuring, there will be some voice. Okay, that voice is showing the flow of high current, right? It is actually showing the flow of high current through the cables, high tension lines, right? So those movement of current is generating the magnetic field around it, right? So if you see the high tension line like this, right? So you should see that the difference between or distance between these lines is there. Why? Because the magnetic field is generated around the cable. If high current is there, higher magnetic field will be created or developed. Right? So you have heard that the high tension line attracted the person. Why? How it is attracted? Because there was magnetic field. He was entered in that magnetic field. That is why it was attracted by the high tension line. So magnetic effect is also there. So in high tension line we can experience this magnetic effect. So placing a compass. Now if you want to see, magnetic field will also be there in lower value, but it cannot attract the human. That is why we generally don't experience it. But there is. So how can you find whether there is magnetic field or not? So we can use the compass. What is the use of compass? To see the magnetic field. So if we, this is the cable, if we shift the compass towards it, there will be needle, and if needle is fluctuating, okay, if there is deflection. Deflection means the movement. Then we can say that there is magnetic field around it. Okay. So if we place a compass close to the conductor, so this was the conductor. So we are shifting towards the wire, then there will be deflection. If deflection is there, it means it is indicating the magnetic field built around the wire. Okay. This magnetic field can be put to a number of uses. It is also used where there is electromagnets. If we want to generate the magnets, right, we have to apply the current to the material, right, like iron, right. It can be used in relays. It can be used in loudspeakers. Loudspeaker means there's magnet uh, behind the speaker. You can see in trains also. In train, we are also using the magnets because the application of magnet is very much in train cases, in relays, in the loudspeaker. If it is not there, it will not work. If you remove that magnet, then it will not work because magnetic field is required there. So these are the two effects that can be experienced, and we can see also. We have also used these things. So I hope this is a sufficient time for today's session. So we will meet in the next session. So before that, I want to ask if there's any doubt to any one of you. Uh, Pawan is asking that what range? Okay, thank you so much. Thank you. Pawan, there is the range selector, okay, in between. If you have seen the multimeter, actually we use multimeter, right? So in multimeter, there's first selector that whether you want to measure voltage, current, resistor. Okay, so first you have to select that, and between that there is also range. So first you put the range. Range means you should know at least that what may be the value of current, right? That there will not be the value more than 5 ampere. So you have to keep the range accordingly. If you are not getting the value, you should increase the range. It means the range is less that you selected. So you have to increase. If you are getting the value in very 0.000, it means the range is selected higher. So you have to reduce the range. So depending upon the value that is showing on the digital multimeter, you have to change the range. If there is no value, it means you have selected very less range, so you have to increase. If you are getting very less value in decimal, you have to decrease it. Okay, Pawan? Okay. Any other question? Anyone? Thank you. If you want to ask, you can raise your hand. Shani, what do you want to ask? Yes, Shani, you can unmute yourself.
Sir, can you repeat that once again?
What?
Sir, can you repeat
What? What should I repeat?
current voltage and
Current
resistant
and
transfer?
voltage.
Yeah.
Okay. Any other thing?
No, no.
Okay. So voltage is actually the potential difference. I told you two things, EMF and voltage. EMF is actually the value without any load, right? It can be said as open circuit. Okay, open circuit
Okay.
means we have not connected any external circuit with the battery, for example. So whatever the value which is showing between positive and negative terminal of battery, it is EMF. Once we connect any load, so the voltage will be dropped across that because load is consuming the energy.
Okay.
Then in that case it will be potential difference, that is voltage, right? And
Okay,
this
sir.
voltage is applied as the force to the any circuit that we want to use, and accordingly there will be movement of electrons, and movement of electrons is current.
Okay. Okay, sir.
Yes. Okay.
Thank you.
Thank you. Okay. Okay, so thank you so much. We will meet in the next session with a new topic. Thank you so much. Thank you. Take care. Thank you. Bye bye. Thank you. Thank you. You can leave now. Thank you.